Where is the other guy? Please text to your friend. Okay. To join the class. I know how to do that.
Professor, don't switch the classroom because it's really hard.
Yeah, me too.
I mean, I'm pretty sure that you are.
Even I have time.
I'm pretty sure your classroom is
Which one? Next one?
the one running.
But
If you can.
without the permission of the registrar office, I need to get the permission, even though it's not usually. Hello? I know this room is not very convenient. I think that there might be a problem of the AC. It usually happens. But the good news is we have only 1 more week, okay, to go. And also your final exam will be the 107. But the bad news is it's very hard to change the room in case nobody knows whether this room is already reserved, but momentarily it's empty or vacant. So if somebody are coming in, so it will be messed up. So even I'm time. So, and very hot, and also hot coffee. Believe it or not, did you check the number of pages that we covered so far in the textbook?
Yep.
What's the number?
7.39.
It's almost 400.
Yeah.
So believe it or not, we covered the 400 pages and roughly the 200 pages for your final exam, right?
Wait, I thought the final exam was
The final exam is after the midterm exam, which means it's chapter 7, deadlock. I think the deadlock, right?
Deadlock.
From the deadlock. Don't forget, many of the students just study memory management and the file, the I/O management, but the deadlock, the last part of the process management is also part of the final exam. Okay, so, but I still remember the first exam in English when after I moved to United States. Okay, that was the operating system. Okay, I took the operating system 2 advanced. The first operating system is waived because I worked for the administrator. So my advisor, actually academic advisor of my old university, waived that one. And second part of the operating system, actually that deals with the basic part of the operating system as well as the distributed operating system. So you know how many pages are covered for that first exam? It's 300 pages. So I don't know how to prepare the exam. Even I was shy to ask the instructor what will be the format of it. What I did is just memorize. Really, that's the first and last time to study such a hard. So, but I don't expect you guys to memorize. Even don't do the stupid thing. But the exam is the exam. Even though I try to do the example or I try to make it easy, but exam is exam. So as I said, the PPT file is a supporting material to help my the teaching as well as your understanding. So I have seen a lot of students who prepare the final exam only based on the PPT file. Okay, PPT file is easy to get overview of that, but it's not. When you read the textbook, at least read the textbook. Okay, you don't have to memorize all of them. You don't have to solve all the questions. I'm using a lot the exercise, but usually I get the idea of the exam question because it's not like the standardized test. So mostly I try to see the difficulty level of the exercise. Then try to make the similar example. But you don't have to solve not all the exercise questions in the exercise are the good questions. Some of them are stupid, some of them are just as the answer should be the several pages. But it's a good idea to start your final exam based on the textbook. Okay? Then when you summarize or when you quickly review the contents, the PPT file may be helpful. I probably have a time to quickly review the chapter 7 through the 13. I don't think we can cover any further the chapter. this semester, but hopefully I try to quickly review if I can finish on time, so we will have a review time based on focusing on the final exam preparation. Any question? But those who are struggling to get a better grade, okay, please contact GA as soon as possible whether there are any missing part. But the best way is you can enhance your performance in the project as well as the final exam. Final exam is still the biggest part of your exam. I need to apply the curve this time because as you can see the average is below the 60. I focus on the average around 75 to less than 80. That is my expectation. In case the value is less than that, I usually apply that. But that the curve may be separated by the undergraduate and graduate. So undergraduate will be evaluated differently. So exam format will be same as the midterm exam. It has a multiple choice. I think one multiple choice question. Than the midterm exam because we have the 2 hours exam. So I don't want for my students to be boring during the exam. It's a 2-hour exam, so probably the more questions but the less tough than the midterm exam. Any question regarding to the exam preparation?
No, only the grade of Canvas is relative. Is the grade that I see?
Excuse me? Excuse me? Yes.
Is the grade that I see on Canvas already curved or not?
Although, when you see the grade on Canvas, please ignore anything. Weighted something or sum of something that is actually created by Canvas. I don't know how to disable that. I tried to disable the column. So because sometimes the quiz is 10 and the exam is 100, it's equally considered on Canvas until I assign the value. But I do not know the weight yet until I apply the curve. So please do not pay attention to the weighted sum or the weighted total by the group or category. Only the point is set. That's your grade currently. Okay? Yeah. Because some of the students complain, I got the 100 in the attendance. Attendance will be less than 5% later. And 70 marks for the midterm, that's huge. That's more important. But because of that, sometimes the student got confused. So don't pay attention to such a weighted or the weighted sum whatever on Canvas. Only focus on your grade based on the scale mentioned in the column. Okay? Any other question? Okay, so we will continue the file implementation. Actually, if we are doing the real project of the file system implementation, it will be a very fun topic. But without such a physical implementation, it's not that fun, but still interesting topic. But hopefully, when you finish this chapter, you should be able to implement the file system by yourself. But to do that, the main difference between the application program, application implementation that you have done in your programming class or the software engineering class and most of your programming experience. From that, the main difference between this one application implementation and the system implementation or system program or the Unix programming or the operating system or sometimes it's called the administrative programming is the data structure and algorithm. Okay? We don't want a fancy, nice interface or graphical user interface for system programming. That is the next level. Okay, first focus on whether your implementation response to the reflect exactly same as what you designed. In other words, the data structure or algorithm. So I have seen a lot of students who are struggling to implement the system, the algorithm, like the scheduling algorithm or file system is another example. Okay, I have seen a lot of students. They can do very well for the application programming or project. So you have the given project, the requirement, so they are successfully done, but not from the system program. not from the operating system. That is because of your lack of understanding on data structure. That's very important. Okay, then once you implement it, once you should be able to implement the algorithm correctly, then you can focus on the better performance or the better interface and so on. The file system, nowadays, many of the application program, actually, there's no clear boundary between application program and system program nowadays. Sometimes it's in between. Your application program need to deal with even scheduling algorithm in your application program. Okay? Also, application program, even think about the web browser. You have Chrome. Even operating system would like to replace, web browser would like to replace operating system. It can be considered as the operating system of your system. Application, so which means when you join the company, like the application program company, you should be able to understand such a system programming and for example, the file structure. So in your application program, you design the data structure of the file and what is the function, is there any other way to improve the performance of the managing the virtual file in your application? Yeah, this kind of work will be helpful. So there are different types of the allocation. So allocation means allocate the block, okay, to the file. Okay, that is the secondary storage, not the memory. Okay, not the virtual space. It's the physical hard disk drive, secondary storage. So first one naive way is the easiest way is a contiguous approach. So in the directory structure for each file, we can specify the start date and block number. Okay. So in other words, if you need to implement a file system with a contiguous allocation, you need to design data structure of the directory. You need to design the block. Okay, you need to design the file, then allocate each block to the file. Okay, that's what you guys need to do. That's the same as any the file system. Okay. And so to address the problem of the fragmentation, especially the external fragmentation, we can make the group extend based system. We can make the four contiguous block as the one extend, for example. Then extend by extend, you can allocate such a thing. That's used in the, for example, DBMS system, database management system, use block by block. It's too many IO. Okay? So why don't we make the group that is extend-based system? So database system allocate the extend by extend to the file. File in database means table, for example, okay, or index. So that is the extend-based system. And also we can consider the linked allocation as a point in each block. Okay, so you can start in the directory structure. You can start to access the file from the starting block. Then each block has a pointer of the next block. Okay, then so on. So now last one is so you can double check whether this is the end of the file. So in this case, we don't have to worry about the external fragmentation, right? But problem is, you can implement only linear search. You cannot implement the random process. And another problem is that slightly you can have the less utilization because of the pointer, like the 4 byte of the address of the pointer. That means 4 byte means around 1%, less than 1%, but it's sometimes maybe 2. And one of the example of such a linked allocation is the FAT. I'm not sure. I think that you guys use the Windows 95 or Windows XP. So can you remember the file system, name of the file system that you used in the old Microsoft operating system? FAT 16 or 32 before NTFS. That is this one. So they use the linked base, not exactly same as this one. It's almost the same. It's based on such a linked list. That's the starting block. That was the reason when, if you want, they allocate the directory structure at the beginning of the hard disk drive. Okay? The beginning of the volume, it has a directory. Why? Anyway, when you need to access the data, you need to start from this starting point. Then it can be anywhere. That causes the problem of the defragmentation. Fragmentation, so you need to apply the defragmentation algorithms or compare algorithms. So from time to time, so during the night, okay, when you watch the movie, so you run the defragmentation. It takes a time. So to compare, such as to address the problem of the file. But if we make the index of each block, then we can easily implement random access. Okay, so using such a block, the information we can directly access the data. So in this case, the directory structure includes the file length, file descriptor with the block ID or code index. Then using this index, we can access the file block. Okay, but if we have many blocks, okay, so the index block size will be bigger. So to address that problem, we can make the index of index. So it can be eventually the multi-level index, or sometimes we consider the something indexing structure for this. For example, B3 or B plus 3 index that will be discussed in the database system. By the way, from time to time, I mentioned about the data structure or algorithm of the database. That doesn't mean the database is the first, then this one. Database, DBMS is later than such an operating system, which means the database employ such an idea to implement the system. So, but nowadays the database is kind of in between operating system and application layer. Oracle, do you know the Oracle company? What is the main business of the Oracle Corporation? It's a database. They actually try to make the database operating system. Can you imagine what is that? That's actually true. What is operating system? It's in between user and computer. So through the operating system, you can access or utilize the computer resource. Most of the database server means the computer where database system, Oracle is running. Is there any other application? No, mostly database. Many people believe the database server is important. You spend a lot of time, invest some money, and reliable and the scalable system is very expensive. It's only running for the database. But most of the time, the user complain, I need to purchase the operating system, which is very expensive, or sometimes it's very hard to manage the database system. Totally depends on the operating system. So Oracle realized the importance of the operating system. What if we cover the operating system in database? So they released such a database that covers the operating system, which means you don't have to install the operating system. You can directly install the database system that has the CPU scheduler and memory management or the synchronization issue. But it's a fail because the people still want the traditional operating system, and the performance was not so good. So idea was good, but similar approach happened in the web browser. Okay? Everything can be, so Google believe, so what if we operate the system, make the operating system that is based on browser? So it's a Google Chrome. So that is one of the ways. So operating system is not only for Unix or Linux. It's not only for the Windows. It can be anywhere. So even it's not easy to make the clear boundary between application layer or operating system. Sometimes there's a mix there. Okay, that is true. So Unix, the Unix file system uses kind of a hybrid of such a previous technique, which is called inode. So inode is one of the popular such allocation method. So in case of the 32-bit addressing format, it can cover up to the 4 GB. So that has the direct block. So in case of small, and the single level of the index, double level. Sometimes it has a triple level of the file. So such a triple level, double level of the index are not better than such a direct block. Okay? So index is a faster way to access find the data block. But anyway, you need to access the index 1, 2, 3, then find the file. What if you have the single block file? You need only one block IO, but because of index, you need to access addition. So to address the problem, inode has the direct one block, then single level, double level, even triple level, depending on the file. So it can cover up to the 4 gigabytes.
So
Yes.
how does it work?
How does it go?
I know how does it work.
So when you create a file, the operating system determines size of the file. Okay, you can get the size of the file, then allocate the if the file size is less than 1 block size. Okay, or initially you create the file, so it's a 10 byte. Then it will be allocated based on the directory. But if your file is the 1 gigabyte, it's a big size, then at the time it requires a lot of the that will be allocated by the trader. It's depending on the file size.
And the direct block will carry more than one file. So you got 10 files having 12
Direct
bytes.
block is the same as, for example, it can be anything, but for example, the continuous allocation. But start and length is always 1. Okay? Because you need only 1 block for the file, in that case you can use the direct. However, if your file is longer, if you have a long file like the 1 gigabyte, you need a number of the blocks. That block should be pointed. At the time, if you are using the direct, the direct block, which means you need 1, 2, 3, 4, 5, so too many, the pointer. Instead, you can use at the time the triple direct block. It can cover in the index, you can cover many data blocks. So that is the difference. Okay, so today we are going to continue the several issues or the topics of the file system implementation. Okay, so in terms of performance, which one will be better? So we have the contiguous, the linked, and others. Index. Well, it depends on, right? If your type of access, the file, is a sequential. So I have the batch job to read the 10 megabyte file sequentially. You don't have to use the index, you don't have to use the link at the time. The contiguous is better. So what about the random access? Linked. Also, in case of a sequential, linked is also better. But it may take a little bit time than the contiguous. Contiguous is the next, so you don't have to worry about. But the linked, you need to find the next block using the pointer, but still it's good for the sequential. So, which means depending on the application type, you can specify in your operating system, you can specify the such allocation type. And this is an example. This slide shows the how much the block I/O is important. Okay, so somebody said maybe curious, so whether direct block or the triple indirect block. It's just nothing but the 3 I/O different or 2 I/O different. But think about in terms of the CPU, the processor, the operation. So this is the example of the new, pretty much the processor Intel Core i7. There is a 3.46 gigahertz. What does it mean the gigahertz? It's a frequency, right? In other words, when you process one instruction, depending on the instruction type, you need 1 cycle or 2 cycles, something like that. Then 1.33.46 gigahertz means it's the per second 3.46. In other words, so roughly 2 giga times of instruction will be processed. So in this case, it's in case of MIPS. MIPS means millions of instruction per second. So MIPS can be used to judge the performance of the CPU processor. How many instructions will be processed per second? So MIPS, in terms of MIPS, 160,000 millions of instructions will be processed per second. It's not my result, it's from the Wikipedia. Then, for example, in the typical hard disk drive, it can the input and output, how many times? Roughly the 250 per second. If you divide it in one I/O, 630 billion. The instruction can be processed. So one I/O difference is huge. Even though in other words, even though you have the very fast the CPU processor, you cannot get the full data. You cannot process it because the reading the data from the hard disk drive is slow. So that is this slide shows how much important to increase the performance of the such a I/O in the hard disk drive. Okay. So nowadays, even laptop and even the desktop try to use the faster. So anyway, the CD-ROM time, the hard disk drive, traditional hard disk drive is slower because of the longer seek time and latency. So we are using the still SSD comparing to the CPU, the speed 2.5 million. Right, per one I/O. So that means do not spend a lot of money when you purchase a computer for high speed of CPU. Okay? It's better at the time buy the more faster, the hard disk drive. Okay? Then depending on even the operating system, depending on the algorithm, okay, it can be varied. The next issue is what about the free space? So once you insert your new hard disk drive and the secondary storage, then what you guys need to do is a format, right? Format means make the data structure. In other words, make the free block. Once you have the formatted, nowadays even when you purchase a new factory level, the hard disk drive is already formatted, so you can directly use that. The file system. But anyway, no matter what types of the file system, it has a free space. Problem is how to manage such a thing. Think about the 1 gigabyte, the size, 1 gigabyte size, the hard disk drive. It was huge when I was working for the company. So first time when I installed when I had a computer, the hard disk drive size is 2 megabytes. Really, it's a 2 megabyte. It's the same size as the current one, but it's a 2 megabyte. Then when I joined the company, so as an administrator, so we first time see the 100, bigger than 100. So think about the 1 gigabyte. So if we have the 512 byte, the block size, how many blocks? So half million, right? Half million, 1K, 1K times 1K is 1 gig, million and thousand, thousand of the million number and 2 times. That is the number of a block. So it has huge number of the block. What if the 1 terabyte? So 1 terabyte is 1,000 gigabyte. So you need to times 1,000. So it means we have huge number of such a free block. It's very hard not easy to manage such a free block. So how can we do that? The first way is that we can use the bit map. So we can assign the one block, one bit. So which means when we have the one by the 1 terabyte, the disk size, we can allocate the 1 terabyte, 1 gig, 2 gig, 2 gig number of 2 gig bit will be used for the bit map. Okay, that can cover the 1 terabyte with the 512 byte block. So we need to make that. If the block is free, we will assign 1. Otherwise, it's occupied. We can assign 0. Then how can you find the free block? We can search from the beginning. Okay. So if you are not lucky, it will be the last one. It takes a longer time. So we can make the such a bit by the word. So word means the 2 bytes, but the 2 byte does not always the 16-bit. Okay, it depends on the operating either hardware system. It can, so we cannot say the number bit per word is the 16-bit. It depends, but mostly it's a 16-bit. Okay, then we can make the group. Okay, then we have the something the offset from that. Then we can manage the free block. Okay, we can easily calculate how many. Then that free list, which one is better? Put in the memory or hard disk drive? Definitely memory is better. That can improve the performance. But that means that if we want to manage the bigger size of the hard disk drive, so we need more memory. You need to cover that. This is the one way to manage the free list. We can have the free liquid the list. Okay, it's a free list. These are the free, so you can allocate one of them. So there might be no waste of the space, so it can be used anyone. But if this one is occupied, you can this point will be changed to this one. Even if this one is occupied, you can connect to this one. So this is liquid free space management. Also, you can consider the grouping. Grouping means you can make the group. Okay, so not always you need just one single block. To allocate the block to the file. Okay, most of the file need several blocks. So why don't you make the group? So you can make the group and make them group so you can allocate together. Okay.
Group of what?
Group of the block. Make the group. Yes.
And in that diagram, those arrows shows the free block or the occupied block?
This one is a free block. Okay. So this is one way. This is not the group. Grouping. So this is just a linked list to manage the free block. Okay. So this one has a pointer of the next free block, next free block, next free block. Okay. The problem is when you allocate the last one, it takes a lot of time. Also, there is one by one. This need the block item. So why don't we make them group? Okay. Then you can manage only the. For example, if you make the group by A block, okay, then you can manage only the first block of each group. So you can reduce the size or the link of the size of the link, the list. Okay. In this case, when you have the group, so frequently there's updated and removed and inserted, used. So you don't know what is the size of the free block of the group. So you can, so in the first block of the group, free block group, you can give the how many blocks, how many members of the free block in the group. Okay, then you can, if you allocate the 10 block, so you can just add up the, you can check the first block with the count, okay, then find the total number of the block. That is the counting. So for the grouping, so you can manage the number of free block of the group as a count. Space math is it's used in the GFS. Idea is nowadays the hard disk drive is huge. It's getting bigger. It's like several terabyte even for the personal computer, and the workstation is easily several terabyte, even petabyte size. And I heard that some of the system is the jet. Nowadays it's called the zettabyte era. Zettabyte is the 1,000 of petabyte. Am I correct? Hopefully. So gigabyte, terabyte, exabyte, zettabyte, right? So it's a bigger and bigger. So to manage such the free space, the block, including the free space, is not easy. So idea is we can divide such a divide space into MetaSlab, the unit. It's a management unit, so it's a divide, smaller size of the file system. Then this the MetaSlab include such a counting and grouping information. What is a free block? Okay, so when they access NOT, it doesn't process first all the file system, instead the MetaSlab, the information. Okay. Then this is the efficiency of the file system. So I think that is straightforward to understand the efficiency of the file system. Okay, so it depends on the allocation, how to allocate, and how to apply the algorithm for the specific file type that determines the performance. Okay. Also, sometimes the pre-allocation or as needed. As needed means that it doesn't allocate all the block to the file. Instead, even though the processor asked the 1 megabyte, but as needed, which means that if the data is written to the block, if needed, then add up. Then we can disregard the overhead, okay? Not allocate the first time. And also the pre-allocation means once the process, the create the file or the need to allocate the file is already allocated in the anonymous the allocation on the hard disk drive. You can just point that the pre-allocated file block to speed up. The reason is that, as we have seen, compared to the CPU speed, it's still very slow in the hard disk drive allocation. So to address that problem, we can even consider the buffer cache. Okay, buffer cache is the we will see the little bit details about such a buffer cache. So we have seen the similar approach in the virtual memory. In the virtual memory, we focus on the process. Okay, if a process even need to load from the file system, load into the memory. It has the instruction, but to reduce the time of accessing, so we can manage the virtual memory. So it's a page in and out. Similarly, we can consider the buffer space for the data file. The process will ask to open the file. Then that data should be loaded into the memory. Then that can be, we suppose that that data file will be reused later. Okay, that is the general idea of the cache. So we can consider such a buffer cache. Even file system is not the memory in the operating system. Even hard disk drive file system itself has the buffer area memory. So some of the, if you spend a little bit more money when you purchase the hard disk drive, or somebody purchase the backup device, but you can use such a backup device as an external storage. That storage has the buffer memory. So instead of accessing the file block in the hard disk drive, so you can access the file from the buffer cache, buffer in the file system. Even that is not part of the main memory, but you can get the speed of such a thing.
You said that we are addressing some problem. What is the problem with efficiency?
The efficiency of the file system. Okay, how to improve the.
So we use buffer cache.
Yes, but this buffer cache is different from the memory area, memory management that we learned in the chapter 8 and 9. Okay, that is for memory space of what? Process. But this is the buffer cache, same idea, but this is for data file block. Okay, we can apply such a same thing. Definitely synchronous will be slower than asynchronous. So think about the. I asked several the question. Okay, so if you stop one of them, the synchronous means until you solve the problem, you cannot go to the next one. It's synchronous response. Asynchronous, you can do whatever. Whenever you have the answer, return that. So when you read the file data, or write the data, the asynchronous is common. So it doesn't matter how long it takes, just as you have finished the job, writing the data, return to the file system. Okay. So, as I said, in the main memory management, we can use such a page main memory as the cache area. Even we consider the virtual memory area. What if we use the same idea for the data block? Okay, so that is the main memory memory map I/O. Okay, that utilize the page cache. Okay. And then how can we differentiate the page the cache for the page cache, and another one is the data cache. If you do not specify, if you do not separate, so if you consider both the page, traditional page, and data cache into one, that is called a unified buffer cache. So if we do not have such a thing, so the cache area, the page cache, it will be separated. So this is in the buffer you can access. This is the data cache, and this is the page that we have discussed in the main memory management. So it will be separated. However, if we consider unified buffer cache, it doesn't matter. So page is a page, the cache is the cache. So it can be used for either data cache or page cache. Okay, so this is more common in current operating system. Okay. It will take a time to discuss about the recovery and such a logo structure. How many of them are taking the database? Just before we discussed the same thing in the database today, right? So same idea. I brief it. So what is a recovery? File system. Okay. How much you believe that your file system, secondary storage, it is permanent? Even though we are saying the secondary storage, permanent storage, if that is crashed or physically damaged, you cannot get the data. So sometimes we need to recover the data using what? Backup data. Without backup, there is no way. the damaged data, you cannot recover. So in case, suppose that we have the backup data. Backup means it's a copy. By the way, when I joined my old company, first company, the first day, my supervisor, the manager, mentioned about this. So there are two important things for the administrator. So at that time, it was the database administrator, sometimes it's called the DBA, and later I was in charge of the Unix administrator also. So there are two important things that the database administrator or any administrator should have. The first one is that is the backup, not recovery. Recovery, you don't have to know. Just in case something happened, you can call customer service. You can call the vendor. You can call the expert. But if you fail the backup, there's no way to restore. So that's easy to say, but very hard. Okay, there are many different scenarios and different cases. Think about your laptop. How often do you back up the data? Not frequently, really. And once a year, that's very often, really. So backup is, so in the company, do you think the old company has such a backup solution? No. Even very big company and the established, well-organized, they fail the backup the data. Also, sometimes they keep the backup data next to each other. Really, that happens. It's a physical. If the backup data is physically separated, so fire or damage it, crash it, you may lose your backup data also. That's the importance of the backup. The more important thing, second thing, what will be? As a data administrator. Backup already is the first one. Recovery, you don't have to worry. You can hire anyone who knows. But backup, if you fail the backup, there is no way. So backup is much more important. Then there is another thing that he said this one is more important than backup. Anyone?
Disaster management.
Disaster? No, you don't have to. You can, if you have money, you can do that. You need to do, but that's important. Disaster recovery and disaster management, especially the after 9/11. Oh, really? So until 9/11, not many people realized the importance of the disaster recovery. They just, even though they have the backup, they put the backup tape next to the computer. So after the World Trade Center collapsed, they lose all the data. Really. Few companies, actually at that time IBM, so almost only one provider for such a recovery solution. And what is the second thing? Nobody? It's the documentation. Really, that's more important than any technique or skill for administrator. He said, are you going to spend entire your life in this job? Definitely not. You don't want to. Even I left after 7 years. So that means for the company, they don't care who will be the administrator, but they wanna continue such a job. How? It's the documentation. In case something happened, so at that time, so how can you see what happened before? It's from the documentation. And for example, database administrator, you can keep updating the data by requesting. If you do not have such a documentation, you don't know how to, what caused the problem and how to go back. So it's the documentation. Documentation is 51% of the administrative job. Any administrative job is a documentation. But not many people are realizing such an importance of the documentation. So in the recovery, the key part is how to keep the consistency. Okay, consistency means, in other words, it's a reliability. So when we, in terms of the data structure, when we access the data, okay? Whether data, the system itself has the system itself provide a consistent information no matter what happens, okay? For example, in case of failure or disaster, whether we can go back to the original state. That is the consistency. Then how can we do that? Using backup. Okay? Then using the backup, we can restore the data. However, what is a backup? You can just copy the current image. You can just copy your hard disk drive. Do you think that is a backup? No. Backup means a logical backup. Okay? Why? While you are updating the data, your system may be crashing, fail. That transaction should be go back or should went back to original or just current. Who decide? That is a logical concept. At that time, you need to consider actually transaction. The transaction is the, I think I did the same thing in the just 1 hour before, right? So, do I need to? Yes, because that is a transaction, because in the database course, the previous class, we did discuss about such a transaction and concurrency control and backup and